Hi students, welcome to the session on causality of discrete time system. We know about causality of discrete time system. Uh, it was defined in terms of impulse response. So, with respect to impulse response, a system is said to be causal if h of n is equal to 0 for n less than 0. Right? This implies h of n is positive or right hand side sequence. Right, it takes only n is greater than 0. For n greater than 0 only it is non-zero value. That means h of n is positive or right hand side sequence like this. For example, 0 1 2 3, it may take values like this. For n less than 0, h of n should be 0. It starts from n is equal to 0 only. Right, this is what a causal system, it is defined with respect to h of n. Now we are going to define causality with respect to system function or transfer function h of z. Right? So in order to define this, we have to know something about causality with respect to h of n. Right? Since h of n is, if you see right hand side sequence, we know from the transform properties for right hand side sequence, ROC should be exterior of the circle. ROC should be exterior of the circle. This we know already, right? And second thing is h of z we can write as h of z is equal to summation n goes to minus infinity to plus infinity h of n z power minus n. That is, the transform of h of n is h of z. So you can write z transform of h of n. Yes or no? So you see that for causal system, h of n starts from 0 only, right? So it won't take negative value. So n starts, for n less than 0, h of n is 0. So my limit will change to n goes to 0 to infinity h of n z power minus n for causal system. Right? Since h of n takes only positive n, that we have seen here, right? Here. Okay. So what happens if I expand this? What will happen? H of 0 z power 0, h of 1 z power minus 1, h of 2 z power minus 2, like that it will go. This indicates ROC of h of z, that is this one. ROC of h of z is everywhere except z is equal to 0. Yes or no? Why? We have known already, right? For right hand side sequence, ROC should be like this one, because it is 1 z power minus 1 is nothing but 1 by z squared. When you substitute z0, it will become infinity. You cannot find. That is not ROC. So ROC should be everywhere except 0. That means for right hand side sequence, ROC includes infinity also. Okay. So these two conditions are derived by considering causality in mind. So combined these two points, what we can say, a discrete time system is said to be causal. A DT system is said to be causal, right? If and only if the ROC of its system function nothing but h of z, system function or transfer function h of z, right, is exterior to the circle. From first point we know, from exterior of a circle, and it include or must including infinity, that it must include infinity, right? So both the conditions were derived by keeping h of n is causal. So first condition states that ROC should be exterior of the circle. Second condition states that ROC should include infinity. So for causal system, a discrete time system is said to be causal if and only if the ROC of a system function h of z should include infinity and exterior of a circle. Right? This is the one primary condition. Second thing is, if h of z is rational, right? If h of z, that is system function, is rational, rational means ratio of polynomial, right? So if it is rational, for the system to be causal, for the system to be causal, right? ROC must be outside the outermost pole, must be outside the outermost pole, right? And infinity must be in ROC, right? Rational function means ratio of polynomial, right? Ratio of polynomial, right? So you see, ROC should be outside the outermost pole and infinity must be in ROC, right? So we know already infinity must be in ROC for causal system. Infinity must be ROC means, what is the meaning? When limit z tends to infinity, it should be finite value. H of z should be finite. Yes or no? That we know, right? So ROC infinity must be included means when you substitute z is equal to infinity, that should give finite value. If it gives infinite value, then it is not in ROC. So when limit z tends to infinity, h of z must be finite one. When this is possible, right? So that is possible only, you see, z squared, for example, I take z squared plus z divided by z cube plus 2z squared plus z11. You see here numerator degree of numerator is degree less than degree of denominator, right? So from this we understand that when limit z tends to infinity, what will happen? It will become finite value. Take z squared out, right? Or z cube. Z squared out means what will happen? It will become 0. So the value is finite. When you substitute z is equal to infinity, right? So limit z tends to, this implies limit z tends to infinity, you take z square outside, 1 plus 1 by z. Here you take z square outside, this is z plus 2 plus 1 by z square plus 1 by z cube. Then z, this cancel. Z tends to infinity means it is 1 by z 0, right? So it is z square I take, it is z. So this will be 0, this will be 0, this will be 2 plus infinity. So the answer will be 0. So it is a finite number. So the thing is, numerator degree should be lesser than denominator degree. Otherwise, if numerator degree is greater than denominator degree, what will happen? Z square minus 1 divided by z. Here numerator degree is greater than denominator degree. If you substitute limit z tends to infinity, what will happen? It will become infinity. So it is not in ROC. Right? So what is the condition? So limit z tends to infinity, h of z must be finite. That means degree of numerator polynomial should be lesser than degree of denominator polynomial. This is the condition, right? So please keep it in mind. If h of z is a rational function means like this, ratio of polynomial. It is a numerator polynomial, this is a denominator polynomial. If h of z is rational function, then this is, for system to be causal, ROC should be outside the outermost pole, that we know. ROC should be exterior of the circle, right? So exterior of the circle means outside of the pole, and right, and infinity must be in ROC. Infinity must be in ROC means the degree of numerator should be lesser than degree of denominator. By seeing the equation itself, you can say whether the system is causal or non-causal by seeing the degree of the function. Okay, so these are all the points we must keep it in mind. Okay, so I hope you understand the concept. If you have any doubt, please ask me in comment section. If I will clarify. Thank you.